By the binomial theorem of the zeta function, the subordinate zeta function located on the critical line can be obtained, and the L function of mod 3 can be derived by the subordinate zeta function. If the subordinate zeta functions 3, 1 and 3, 2 are calculated up to 100 terms of zeta functions, there is an error of more than 13 decimal places at s equals 1/2. And even when the imaginary part a increases, there is an error of more than 8 decimal places. The sum of the subordinate zeta functions 3, 1 and 3, 2 is equal to the zeta function of 1 minus 3 to the power of minus s. And the difference between the subordinate zeta functions 3, 1 and 3, 2 is equal to the L function chi, 1 of mod 3. If the red subordinate zeta function 3, 1 and the blue subordinate zeta function 3, 2 are equal to each other, it is a non-trivial zero of the L function chi, 1 of mod 3 at imaginary part a equals 8.0, 11.2, 15.7, etc. Also, if the red subordinate zeta function 3, 1 and the blue subordinate zeta function 3, 2 are symmetrical to the origin, then they are non-trivial zeros of the zeta function with opposite signs, of which imaginary parts A are 14.1, 26.0, 25.0, and etc. The subordinate zeta functions 3, 1 and 3, 2 do not have zeros even if they go up along the critical line, and they are not symmetrical to each other. However, the symmetry of the subordinate zeta functions 3, 1 and 3, 2 makes non-trivial zeros. In addition, the symmetry of the subordinate eta function also makes non-trivial zeros of the extended L function by the eta function. However, the binomial theorem of the subordinate zeta functions 3, 1 and 3, 2 is symmetrical, and since one equation is a sum, the other equation is an alternating sum. So the L function chi 1 of mod 3 can also be simplified further. The numerator and denominator of the gamma function of the binomial coefficient can be represented as a product, but if the binomial coefficient of the gamma function is inverted together with the zeta function and the L function, the gamma function disappears. Therefore, the L function can be expanded again into the negative zeta function and can be represented by the symmetry by trigonometric functions. Although the inversion of the zeta function and the L function does not prove the Riemann hypothesis, the proof of the Riemann hypothesis may ultimately be to find and prove the symmetry of the zeta function.